Hi, I'm Ashok from Bangalore office. In this video, I will talk about a logical replication in Postgres. Um, Topics covered in this video are what's logical replication and logical replication methods. There are two major logical replication methods. One is using the triggers, and another is using the logical decoding. Logical decoding is a feature which was added in Postgres 9.4. So, what's logical replication? In logical replication, changes made on one database are tracked. These changes are mostly human readable form. It could be of SQL or XML or JSON. If you're replicating these changes to another database, the changes would be of SQL form. These changes are then synced, or you can replay those changes on another database. By this means, you could replicate the changes in one databases to another database. So logical replication uses publisher and subscriber model, in which more than one subscriber can subscribe to more than one publishers. In trigger-based replication, changes made on the master databases are tracked by the triggers, which we install on the tables. These triggers will track the changes and report that change and store the changes in some tables. These tables we will call it as a catalog table. These changes are then fetched from these catalog tables and applied to the another database in the SQL form. Implementation of these the trigger-based replication differs between the tools. So there are majorly three trigger-based replication tools available, which are also supported on RDS. One is Slony, Bucardo, and Londeste. But all these tools have mostly have the triggers. Will install the triggers on the tables, and these triggers will store the changes on some tables, and there will be a daemon running on some EC2 machines or some other on-premises machines, which keeps on polling these catalog tables and then replicates the changes to the other database. So this is how the how this is a vectorial representation of how the trigger-based replication works. First, we will install the tools will install the triggers on the tables which we want to be replicated, and then these trigger whenever once the trigger is installed on the tables, whenever we make the changes to the tables, the trigger will start at tracking those changes and store those tables in the store the changes in the another catalog table. That we will be so most of the tools will be having a daemon running somewhere, either in EC2 machine or on the on-premises machine. So these daemons will keep on pulling this catalog table from now and then fetches the changes from these tables and apply the changes to the slave databases. The slave database will also have the triggers placed on the tables in order to stop doing the inserts and updates on the slave database. So in order to avoid inconsistency between the master and slave database. Following some of the points to notice about trigger-based replication. So trigger-based replication allows us to migrate the database between the major versions. For example, if your repository is running on 8.4 and if you want to migrate to 9.6, trigger-based replication is the only solution right now. You could migrate it from 8.4 to 9.6. And replication is done with more granularity within trigger-based replication. We can configure to replicate only certain set of tables to the target database, and you can also have some set of tables replicating to another set of databases. So there's more fine tuning you can do with trigger-based replication. No automatic DDL replication is allowed is supported in trigger-based replication. We have to manually trigger the DDL replications, and trigger-based replication suffers from write amplification. For each DML performed on the master database, write has to happen on actual tables and on the catalog table, which doubles the server IO operations. Most of the trigger-based replication tools are asynchronous. That is, the changes made on the master database doesn't wait for the changes to propagate to the slave database. So it is mostly an asynchronous kind of replication. Replication using logical decoding. Logical decoding is a new feature introduced from version 9.4. Audio started supporting the logical decoding from 9.4.9 and 9.5.4 and above. Logical decoding works by converting the well logs into an understandable format like SQL or JSON format. The decoded vals will be again replayed on the master and the slave database um, in an SQL form. The logical decoding can also be used for auditing purpose. So to keep track of the changes, to audit the changes made on the tables on a particular table. Or you can also use to replicate to another relational database like MySQL or Oracle. For decoding the vals, we need to create a application slot, logical application slot, which is different from our physical application slot. And with the logical application slot, we need an output plugin. The output plugin is a library which is the one which tells us in which format the vals to be converted. For example, if you want to convert the vals to an SQL form, you should there is a output plugin called decode underscore raw. And if you want the val to convert to the JSON format, it's here there's an output plugin called val to JSON. With RDS, RDS supports only test underscore decoding output plugin, which defaults comes with the Postgres, and these vals are streamed in these converted vals are then streamed in the replication slots. The application we will while creating the replication slot, we will name the replication slot, and a consumer can consume from the particular replication slot. If you have different application, then for each application, we may need to create a separate replication slot for each application. So each slots will produce the changes only once. Once the changes are consumed from the particular slot, the changes are not reproduced by the same slot. So the changes once consumed is consumed and you cannot be reproduced. With this, we will be ending our session. So in this session, we have seen about logical replication and what are the methods of logical replication. One we have seen trigger-based replication and replication using logical decoding. Thanks for watching this video.